Welcome to the June 2021 Kansas City Java user containerization using Spring Boot applications with Jib and with Ashish Choudhary. And he's here to speak about Jib. And again, welcome to the Kansas City Java user group. And I'd like to thank our sponsors. CRL, Clinical Reference Laboratory, is my employer, and they're sponsoring our meetups. And YRC Freight is sponsoring our physical meetup location, which we hope to join soon. Java News Month. JDK 17 is in ramp down phase. The development of it's complete. They're targeting for JDK 18, which is not the long-term release, but the next release is JEP 405, record patterns and array patterns, and it's a preview of it. And if you want to know the details, it's JEPS 405, and I'll go over it a little bit. So it's dealing with record patterns and array patterns and with the instance of method. So before, when you say like instance of point and then you put a p there, as far as you can on newer versions of Java, you could start doing that p dot whatever. In this version, you can declare that it's an instance of a point, x and y, and then you immediately have access to x and y without having to declare it. And it really helps with the kind of compatibility of these records and these objects and arrays to get it out. Here's an example of an array of strings. So if you say something is an instance of string array, and you declare string 1, string 2, blah, 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 then you can directly access the string 1 and string 2. So if you have time to learn about this, they have a presentation on YouTube for more information about pattern matching and OpenJDK development process and what the ramp down means. Go to this link and it'll take you there. Releases. So we had Kotlin 1.5 released and OpenJDK 11 and 16 builds from Microsoft in Windows, Linux, Mac OS. We had Spring Boot 2.5 and 2.5.1 have support for Java 16. And Hibernate 5.5 had optional JPA 3.0 support and also switched to the Jakarta packaging. In other news, we have KCDC this year, September 15th through 17th, and go to kcdcinfo.com, or no, .info and not .com, and tickets are on sale, and it should be a good gathering for everybody. And anything else we missed? So how to get involved. Attend the meetups when we meet in person, or share this YouTube link with your friends. Like and subscribe to our YouTube channel. Suggest topics, speakers, and locations. You can volunteer to speak by going to papercall.io/KCJug and get notifications on Twitter at KCJug. And provide feedback. So there's a Google form for feedback. And now I introduce Ashish and his presentation. How you doing, Ashish?
Hey, hi.
You got your presentation up?
Yep.
All right.
So I hope you can see my screen, right? I mean, you can see my presentation.
Yes, I can see it. It's not maximized though.
Yep.
There we go. Thanks.
Okay. So yeah, just let me know when I can take over. I mean, I will start.
You can take over. Ashish, you can begin.
Yeah. So you can hear me, right?
Yeah, yeah.
Yeah. Okay. So yeah. Hi everyone. Welcome to Kansas City Java User Group Meetup. My name is Ashish Choudhary, and today the topic for this session is how you can containerize Spring Boot application with a tool called as Jib. Jib is it's an open source tool developed by Google, and we can say that it's a modern day containerizer for Java developers. And so this is pretty much. So I will quickly go through the agenda for this session. What we are going to be covering. So we will start with like why containers, like what advantages do we get of using containers, and then we will cover a small use case like if a Java developer has to containerize their application using most popular way, which is again the Docker. So like what will be his journey or his or her journey around containerizing their existing, or the application, Spring Boot application or a Java application, like whatever they want to containerize. And then we'll talk about like how Jit can help in ease those pain points that you typically that we as a developer typically face, or sometimes you don't even know that this problem exists, and we just use tools that something we are able to containerize our application, and things are working fine, but there are a lot of things that can be improved, or or changed. And then I will talk about features of Jib, and obviously we'll be talking about how we can containerize our application using Jib, and then I will be quickly explaining like how Jib, when it containerize your application, Java application or Spring Boot application, how the image layering is done, and then we'll do a comparison like when you do containerize your Java application using Docker versus Jib, and then there will be a quick demo. So we will use three methods in the demo using that we will cover during our presentation. So we'll see Jib in action in that demo, how we can use Jib, to containerize our Java application, and there will be a small comparison that I did myself. And so this comparison is around Jib build packs and Docker. So build pack is Spring Boot way of containerizing your Java application, and I would not say this is a new feature, but it's been for a while now, and I think we should keep an eye on the feature. So we'll be covering that as well. Then there will be Q&A. So this is just not a specific slide for Q&A. Maybe in between, if there are any questions, I will be happy to answer them. And there will be some references after this presentation that you can go through, some GitHub links and some articles or some for your own learning that you can go through. And last slide is just about myself, how you can connect with me on Twitter or LinkedIn or something. So okay then. About myself, I work for a financial services company, and my work location is Pune, but so I am actually based out of India. So this session is directly coming live from India. So due to this pandemic situation, I moved to a different location. I am staying with my family members. So I'm currently in New Delhi, India, and I am also a tech blogger, and I write about Java, Spring Boot, DevOps, anything related to cloud. And I have a book coming up. It's probably going to be released, I think, hopefully in the month of August. So I'm really looking forward to that. Uh, so yeah, so that's pretty much about myself. I think we can get started. Uh, why containers? So so Docker really introduced us to containers and the whole world of container sites. So right from beginning, I think in year around 2013 it got introduced, And since then, I think currently, if you see, right, Docker is still the de facto standard of containerizing application. I mean, irrespective of language, I mean, whether you are Java shop or you use Go, Python, so it's still widely popular and I mean the most used option. Uh, so what benefit do we really get out of containers? So the why part is so once you move into start your container journey, the immediate benefit is that cost effectiveness. So instead of uh, uh, relying on these VMs or the old school way of using everything as a bare metal machines for your deployment. So we have these small size containers that can be run easily on existing VMs, and you can actually, so it's very easy to spin them up, and using your existing infrastructure you can take advantage of containers. So uh, so you don't have to invest high on your infrastructure part. And again, these are lightweight. Containers are lightweight and easy to use. You can so for example, they don't really so containers are not a full blown version of your operating system, so they only carry whatever required to run your application smoothly, so your dependencies, your runtime environment, and all those things. And then they definitely do provides isolation. So with isolation, I mean you might be having imagine having to run an application which uses a same library but a different version of same library on VM. So but containers provide that isolation, that you can use multiple application on the same VM or different host at the same time, without interfering with each other. And then you obviously get a consistent environment. And so with consistent environment, what I mean, so containers in general are immutable. So once you create a containerized image version of your application, so whether you run it in your dev environment, staging, or production, the application should uh, uh, work or behave the same way in all the environments. And it also the solve that typical works on my machine problem that we as a developer use this term that it works on my machine, but uh, sometimes it doesn't, when the containers usually, I mean, actually solves that problem for us. And obviously if you have microservices architecture, then they are easily get fit into that ecosystem. Because I mean, so with microservices, what you have, you easily spin up micro instances and you bring them down. And so with containers you can easily do all those things. You can just throw away and bring up a new cluster. And if you are using container orchestrated tools like Kubernetes, for example, then so things get a lot easier with containers. So if a Java developer, uh, if you ask a Java developer to containerize a Java application, like, so what is going to be the path for him? So I mean, what steps he is going to follow, or he or she is going to follow to containerize their application. So first step is obviously, I think, uh, I'm saying Docker because this is the first step that in general people usually try, because we play around with Docker all the time. So even on our workstation, when we want to try out few things, maybe we want to do some analysis or some proof of concept, so you can just spin up a Docker instance and then you can just do it. I mean, it behaves the same way as I said in all environments, so it's pretty easy to do that with Docker. So that is again uh, the obvious choice that comes to your mind. So imagine having a use case where your this is a typical user stories sort of scenario where your, I mean, project tech lead or your product owner comes to you and say that, hey dude, I want to build a microservice, and we want to containerize it, and the end goal is to run on Kubernetes. And So what would be your, uh, I mean, how you will go about this problem solving it? Like, so okay, so few moments later, so what you will try uh, to do is, obviously you are to find a solution for something in today's world. You are just a Google search away. I mean, you can do a Google search. You will, learn about lot of. It will give you definitely some option that you can use for containerizing your application, and Docker might be one of them. And then, so as you are already seeing, Google is already suggesting you to use Docker. And so once you maybe you will go through Docker documentation, maybe some tutorials or some plural site course or some YouTube tutorial, something you will definitely go through, because you are just starting your journey. You don't know anything about Docker now. And when and so you and so Docker, how it works typically is, you have your Docker file, and in Dockerfile you specify your instruction, and so there will be some command. It's sort of like a blueprint for your application, which specify like what you are going to, what is the end goal, and how you are going to containerize your application. So Docker understand Dockerfile, and so this is a very minimal Dockerfile that you could come up with once you do some Google search and learn something that I have to containerize my application. And this is maybe what we can say, uh, think, sorry, so I'm just want to hide this thing. Yeah, think, yeah. So, okay, so yeah, so what I was saying is that uh, yeah, so this is a very minimal Docker image that you could come up with after doing some your analysis uh, with what is the best approach for you. And this is a very minimum Docker image. And then, so in this Docker file, what we are doing is we are using OpenJDK 11 base image, and then we are just copying the. So I think there is some sound coming with the fan, so I just switched off my fan. Okay, so what? So yeah, so we are so expectation here is that we already have a jar available for us, and then we are just using the copy command or instruction, and then just uh, just creating using that jar for this Docker file. And then in the entry point, what we specify is the final executable. So when you run your Docker image or your containerized version of your application, so it should run java-jar, and then it should just execute your the jar. So this is a very basic Docker image that we could come up with, but so I will just try to highlight the problem that could come up. So one is obviously that we are using the OpenJDK 11 base image. So this is the base image size is going to be huge in this case. I think it's typically around 650 MB or something. And so, and imagine having to use that just for a hello world application. I mean, do we really need to do that? And another thing is, we first have to build or create a jar of our application using Maven commands like Maven package or ambient clean install, ambient package, something like that. And then we can run this Docker file. So there is a two-step process over here. And so these are the some of the issue that could, I mean, this is not going to fail your application or something, but we could improve further on this approach. So if you realize, if you're smart enough to realize that this approach is not, I mean, best, following the best practices or something like that. So maybe 5 hours later, I think I have given a small time. Maybe after a few days or something, you realize that maybe I can do better and create some better images. Then you probably end up reading this best practices article around available on the Docker documentation. So there are tons of best practices that Docker suggests that you should follow typically to to get create an image with the best practices that Docker suggests. For example, in the previous example, if you see, and I'm just going back to the same slide again. So what really happens initially is that, so when you do run the Docker build command, right? So everything that's available in your current directory, it's get loaded into using a thing called as, so your entire build context get loaded to the Docker daemon. So if you have some secrets or some unnecessary file, uh, then those also might get added in that case. So we can avoid that, and there are tons of other guidelines that Docker says that you should use multi-stage build. So we'll talk about them. So multi-stage build allows you to create a slimmer image version of your uh, application. And similarly, there are many other best practices that you need to follow, to finally get something meaningful that you can run actually in production. So this is whatever we have done so far is fine for our use case. Maybe we want to test out few things, so it works in that cases, but we need something up and running in production, so we definitely have to follow the best practices around that. And then this is similar. So this is the multi-stage way of building a Docker file. So in multi-stage build, what actually happens is you have, so as the name suggests, so you have different stages of your creating containerized application for your image. And so in this example, if you see in the first part, what we are actually doing, we are now, earlier the we have solved that earlier problem. Now we are building everything inside the container, even the we are creating the jar inside the our container image. So the first step, the output of the first stage is in the jar of our Java application. And then the final image we are going to use is the OpenJDK JR Slim version, which is, so we don't need JDK for running our Java application. We just need the JRE, and then we just copy whatever we have built in the previous step in the second stage of the build. And then the entry point, we simply do the same thing we did earlier. We just run the jar. So in this process, we the gain is that we have a slimmer version of our image. But the so in both this process, what is actually happening is that you create so we are not really focusing on the layering our application image layers. We are not really focused about. We are just so it will end up being a single image layer. And if you change anything, for example, in your source code, or if you change anything you change any remove or add new properties, and if you add a new dependency, in those cases your entire application will be rebuilt. So we'll see that in our demo also. But so this approach is good. You will get a much slimmer version of an image, but the image layering part and the dependency on Docker is still there. So maybe there is a better way to build container images. That's what the problem Jib is trying to solve. So let's first understand, like, what is Jib actually. So Jib is, as the name suggests, it's a Java image builder. It is open source tool, basically developed by Google for Java developers. And so we, as a Java developers, are, I mean, we use Maven and Gradle all the time to build our Java application. So it's perfectly fits into that ecosystem. And so it's as easy as adding a plugin to your existing Java or Spring Boot application, and just running the commands. So So yeah, so some of the features that Jib provides is that it's daemonless in the sense that most of the tools, like for example, even the Spring Boot build pack integration that comes up, it depends upon Docker daemon process, and it doesn't require Dockerfile, but it has a dependency or Docker daemon process, so it can uh, build or push your images to wherever you want. And with Jib, you don't have any such dependency on Docker at all. You don't need doc. You don't have to even install Docker on your system to containerize your Java application with Jib. Um, okay. I don't see the cursor. So yeah. So as I said, it doesn't require any Docker file or has any dependency with the Docker daemon process or anything. And then it comes with built-in Docker practices, and so you don't really have to. So all the steps that we have seen in the previous slide, you don't have to do all the. You don't have to apply these best practices with Jib. It comes with its own opinionated way. It has its own smart way of handling things when it comes to containerize your Java application, and it's pure Java. It's written in Java, and it's available for use as a plugin. It even has a CLI version, which I think if you have uh, other if you are not using Java related application, you can use it, that CLI version, for your Python, Go, or Rust app, and it works fine for them. And it's very easy to configure it. As I said, that you just add the plugin and provide. It as I said, it provides its own opinionated way of containerizing your application, which works really well for some of the default use cases. And it so you don't even have to in some of the cases you don't even have to specify your base image, like which base image you would want to use it by default uses a distroless base image. And so I will talk about that also. And then next point is it deploys faster with its own optimized image layering. So what that means is that so it divides your image layers according to your application structure. Like you have your classes in your different image layer, your dependency will be in different, and obviously your resources, properties file, whatever you use, they will be in different image layer. Advantage with this approach is that, so once you do any changes, suppose you are doing we I mean we all most of the time we do code changes in our Java files. So we just did code change, and then so only that part is going to be rebuilt or pushed to a container registry. So that way it's really handled that really well, and you don't have to push the entire application every time. You just it uses its own caching mechanism and pushes only the relevant part which is changed to your container image registry. Obviously, when first time you will run, the entire image will be pushed, but in the subsequent build, it takes care of only pushing the part which is changed. And as I said, it uses a distroless base image, and so distroless base images are language specific images. It is available not just for Java, but other like Python, or I think other languages, Go languages as well. So advantage with them is that they only include whatever is required to run your application. They don't comes with package managers or shell or something like that. So that also reduce attack surface, since we don't have a shell running. You cannot really do SSH on your containers. So I don't think we really need to do that in production scenarios, but there are ways if you wanted to use it in let's say your development or something. So you can there are different ways you can do that with distroless base image also, but I don't think it would be recommended approach for production. However, there is a change being done in the recent version of the jib in the latest version, I think starting with 3.0. So the change is that it has moved away from distro-less base image to adopt OpenJDK base images. So this change, you can still use the distro-less base images. It's just that it's not the default behavior anymore. So, and another thing is that you get a reproducible build with jib. So your container registry on your different tools like Docker or Kubernetes, for example, treats your images differently. So if you're trying to build the same image again, so it removes all those timestamps or user group, anything which comes interfere with the or changes your image struct or your image digest. So it takes care of that. So if your input is same, then the output is going to be same. And it has a very neat integration with Scaffold. So Scaffold is another tool developed by Google, which basically um, it's basically a tool used for development purposes, it, to basically fasten your inner development loop while you're developing application for Kubernetes. And so it really integrates well with Scaffold as well. So generally people use Jib and Scaffold together, because the end goal is to put everything in Kubernetes. So it has that integration. So how do you use
Yeah,
Jib? Yeah.
we have a question, and I don't know if it's something that you're going to get into later or if you can talk about now. Is Jib easily reconfigurable if your build app or org have special requirements?
Yeah, so it's configurable. It's not like you cannot configure things. For example, you can pass JVM flags, environment variables. I think you can pass them. JVM flags, I'm pretty much sure you can pass JVM flags, or you want to containerize the application using your own needs. So it has its own Jib extension framework, so which allows you to do customization with the way you want to build your application. So yeah, so you can do customization the way you want. So does that answer the question?
Yes, thank you.
Yeah. So how do you containerize your application with Jib? Uh, so it's a two-step process. So if you are using, for example, Maven, then you just have to add the plugin. And in the configuration part, if you see in the example that I have used, you don't have to specify a from image tag. You just have to configure the target image container image registry which you are going to use. For example, in this example, I am using Docker Hub, and but it works pretty well with any of the container registry like GCR or whatever cloud vendors are available for AWS. I think it will work. Same for Azure. And even if you have some private registry, I think it will work. And then you just have to run the jib build command. That's it. And again here, I think the question, to answer that question, in the configuration you can specify a lot of things that you want to uh, build the image in your own way. But there are, as I said, there is a jib extension framework that can be used if you want to tweak the build process, how jib builds your images. So that can be used. And this is again option for your Gradle images. And so the process is pretty much the same. You just add the plugin and then run the command. And so yeah, let's talk about jib image layering. So for a so as I explained in the features part, it's pretty much so your application dependency, resources, your classes, everything is into a separate image layer. And the advantage with the is that you get the speed with your build. If example, if you are using you are using jib within your CI/CD pipeline, and so everything is segregated, so only whatever you have changed in your last commit, that part only get pushed to a container image registry. And so this is how it defines your image layers. And yeah, so this is just a typical zip versus docker build flow, like how you build with docker as compared to how your builds are going to be with zip. So with docker, what really happens is that, so you have a Java application, then the first step is before even containerization, you have to create a jar for your application, and then your docker file comes into the picture where you specify how you want to containerize it, and then you use command like docker build, and then your everything gets from build context loaded to your docker daemon, and then your docker daemons comes into the picture, which creates, which containerize your Java application. And then finally you use docker tag and then docker push command, to finally push it to a container image registry. So there are a lot of steps in there. So with Jib, as you can see, the process is pretty much straightforward. You just have your application and you add the plugin, run the command, and the output is that you have a container image available, pushed to a container image registry. For example, I mean, Docker Hub or something. So this is the very simple way, you know. So it's pretty much really simple with Jib. So yeah, so if you were to write a Docker, I mean a Jib equivalent Docker file, this is how it is supposed to look like. I mean, you can go through it, but the purpose just want to show that you can containerize your Java application the way Jib does, using a similar Docker file. But again, you are going you to be using Docker and related technology. With Jib, you don't have to really depend upon all those stuff. Okay, so yeah, so time for a demo. So I have to get uh, out of display mode, and I'll just share my ID. I hope it's clearly visible. Um,
It is.
so in this demo, what we are going to cover, we will try to containerize our application using different methods. First, we'll try with the Docker simple method with a very basic Docker file, and then we will use the Docker multi-stage build, and then we will use Jib, and we will also explore Spring Boot build pack option. So we'll try all these methods. So this Spring Boot application is very basic, simple hello world application. I just have exposed this slash hello endpoint. So whenever you request that endpoint using curl or browser, you get this string message. And so since we are going to be first starting with the Docker build, so this is just the image that we are, I mean, the Docker file that we are going to be using. And so this is the same Docker file that we have seen in the slides. So let's just try to containerize our Java application. I am not going to be going to the pom.xml. I will come to that when I will explain the zip part. So we will just use the option available for us as a Docker file for this initial setup. And yeah, so, okay. So I'm just looking for my terminal. Yeah. So I hope you can see my terminal screen. So, so I will use. So I'm already in the present working directory is my source code, and then I will just run the Docker build command, and build the create and containerized version of our Java application. I've just specified the tag name, and then we'll just run this command. So it first it will try to pull the base image. So uh, I just wanted to show like whether we have any images available in my local. Okay, yeah. So I think it has created the containerized version of our application, and yeah. So the thing to highlight over here is that the image size, if you see, it's around 664 MB, and so this is I'm not sure if uh, you're going with product going to production with that image size, and next method is we will be using sorry, I just have to you know move this windows. Yep, that's better. Okay. So yeah, so this is a very basic setup of containerizing Java application. So next, what we will do is we will use the multi-stage build. So I just have that Dockerfile already readily available. I will just use that. Uh, I will just going to be replacing this with the multi-stage build, and so this is the multi-stage version of the Docker file. It is similar to what we have used in our slide, and so let's just build the same application with this command. So we'll just rename it multi-stage just to be sure that for verification. So what if you see that it's trying to use the stages, different stages. So we have two stages. So it's using uh, trying to download. It's parallelly trying to download the other base images as well. So it's already starting download. I think it has already downloaded the base image version for our first stage, and then it's so now it's trying to create the jar of our application, and so this process actually takes some time because so now what we are doing is we are inside our container image, and we are building our application, or to say that we are building our jar first, and then we will use that jar or the output of the first stage of that Docker build into our final image. So it tries to download the required dependencies. Uh, so this is actually the problem that I was highlighting. I mean, we are just running it for the first time, but if you run it in the subsequent run, if you do any code changes or something you changed in your application, then the caching gets invalidated, and it tries to download and rebuild your application. Obviously, it has to rebuild it, and if there is no changes done, then it is fine. But if there are some source code changes or something you change in your application, then this entire process will be repeated. So this actually, so it's already, if you see, it's already taken a lot of time, and we are just running it for the first time. But the process is going to be same if you change anything in your source code. So it just looked at your POM and tried to download the dependencies again. So it's trying to download all the required dependencies.
While we're
And
waiting, there's
yeah.
a question from random guy. Can we use Jib to deploy applications in AWS also, or only in the Google Cloud?
Okay. Yeah, you can do that. I mean, I would not use the word deploy. I would use, I mean, it doesn't do the actual deployment. It just push the image to a container image registry. So yes, you can use AWS container registry, uh, or Azure, or whichever I think even for private registry it works. So you can do that. So yeah, the process to do that is, I think you need to use. Obviously, you have to provide some way for Jib to authenticate with those repositories. So there are methods available within the Jib plugin itself that you can use, and use those methods to authenticate and push your image registry to container image registry of your choice. I mean, whichever you uses in your application.
And I have a question, like why is it better to build the jar inside the container and like run Maven inside the container versus the more traditional way of just building it locally and then including the jar?
Uh, um, so, uh, actually, the benefit here is with multi-stage build is that you have the choice of change your base image. So, in the example, if you see, like I'm using, since I'm building inside container, I obviously need my build tool as a build tool. I need to have that build tool inside my container image, and so you the outcome of this multi-stage build is going to be that you get a slimmer image of your Java application. So
Okay.
earlier, yeah, so earlier, I think in the example I've shown that the simple Docker image is around 664 MB, and with multi-stage build you get a slimmer image because we are not using the entire JDK. We are just using the runtime environment which is required, and the jar which is required to run our application. Yeah, so man, it's taking a lot of time. So yeah, so this process may take some more time, but that's I mean, you gain something but you lose also something in this process. And so I don't think you can probably use this approach for your local development, because I mean, you so if when we are developing application locally, we want the development loop to be faster, right? We want everything to, whatever change we do, we want to see it instantly, right? But I think in this approach, it takes a lot of time. So I think it has finished the build, and let me just see if we have the image available. Yeah, so we have the image, and if you see, the image size is much more, I mean, it's uh, reduced. Yeah, so it's just around 237 MBs, and as compared to our initial version of the Docker build that we did. So this is the benefit of using multi-stage build, as I was saying. And the next example that I would like to show is you know, the Jib version of that. So I already added the plugin, and sorry. So let me just explain the parts here. So maybe I can remove this part also, the from image tag, and we can, just build with whatever the Jib Maven plugin provides us with, the default base image. So this is pretty much, you specify the plugin details, you provide some configuration, and the image, the target image registry we are specifying. So I'm using my own Docker Hub registry, and this is going to be the image name of our application. So let's just reload the Maven project. Oops. I don't know, sometimes it gives this weird error. Um, so
I get that weird error sometimes.
yeah.
Just want to let you know you're not the only one.
Oh yeah, so you do also get that. Maybe I have to file a bug in IntelliJ IDEA. Okay, so it's, yeah, man, it takes this indexing. Okay, okay, so yeah, so So now what we'll do is we will just run the Maven, will compile our project and do simple git build. What I did, I already had the plugin. I just removed the comments and then I'm just using the git build command. So yeah, so about the way it works with registry is that it tries to look for your credential from your typically from your config.json file from Docker if you are using, but so you can use I think the Maven settings.xml file also where you can specify your username and password to authenticate with your container image registry, but don't just put them in the plain text format. And yeah, so I think the build is completed. So I actually wanted to explain something in the output, but let's just see. Sorry. Okay, so my bad. So why I'm checking it my local. So the image is already pushed to the Docker Hub container registry. So I think I already have that image available. Yeah. So I don't have any image, but if I just refresh the screen, I should see it now. Yep. So that's pretty much it. So it's the name of the image that we have given in the pom.xml file, and we could see. So it's pushed a few seconds ago, I think, around the same time. And so yeah. So the image is. So what we have done now is we have used a zip plugin, and zip has not only containerized our application, it has it it so you will not see the image in your local Docker daemon, for example, because it doesn't use that, right? So we have the only those two images available because the image is already pushed to a container image registry, and
Can we see the size and the Docker image registry?
yep. Not sure if you can see the size.
Or you can download a copy of it? I don't know.
Yeah, I mean the size that's it shows over here, it's compressed size, so it's not the actual size. So I can do a Docker pull, and no, so I will just download it. Yeah, cool. So the image, we'll try to download that image now. So it has started the image extraction process. It's trying to pull all the image layers. Sometimes I think it does parallelly, but I don't know. I think it does parallelly. So it has pulled down a couple of image layers, but we'll see like what is the final image size after this pull is completed. Okay, cool. So let's run the same command. Yep. So we have the image available, and yep. So 217 MB. It's much even lesser than the Docker multi-stage build. So it is really cool. And yeah, so one thing that I wanted to highlight that so uh, another best, I think this is best practices in general with containers, that you should specify image digest for or maybe use deterministic images, so that uh, so when you pull your Docker images, right? So uh, or so in this example, if you see that it's using this image with this SHA-2 hash, right? But we have not specified the image digest. So in this process, what it will try to connect with your container image registry every time you do zip build. So if you want to avoid that network hop, you can specify image digest, so that it knows that it doesn't have to always. So default behavior is always to check the container registry to verify whether you're using the. So it always tries to use the latest, but we should or try to stick with the image digest version. And so this is and another thing is that this is how your image layers are typically available inside your container. This is how your application images layers will look like. You have app resources, classes, and libs. So we can actually look inside our images if you want. There's a tool called as type. Sorry, so it needs image ID. My bad. So we'll provide it the image ID, and then we can, I mean, we just wanted to see like how the image, how the layering is done inside your GIB image. So it, yeah, takes sometimes it take times, but yeah. It's with dive you can actually see inside the contents of your images. So yeah, so all these layers which are coming, as GIB Maven, these are created by GIB itself. So you have on the right hand side, if you could see, you have your dependencies, libs, whatever the Spring Boot application is using, and then think. Yep. So these are your application image. Sorry, the compiled classes. So this is how typically your images looks like, and if you see the total image size is also at coming at the left hand side at the bottom. So yeah, so this is how your image layering is done, with JIP. You just exit out of it, and maybe I think we can run the can run it as a Docker container, maybe, I think. So whether we'll get to know whether the application is actually working or not. So I have these commands already copied. So I will just run this command, and so I just need an image name. And yeah, so yeah, this is our image name. So already exposed the default 8080 Spring Boot port over here, and then we'll just remove the container after we are done with it. With the I have provided the -rm flag, and it will just run it in the interactive mode. So yeah, that's it. Okay. So the image is locally available. It doesn't need to do anything. It just use the locally available image, and the Spring Boot application is already started. Yeah. So it took around 11 seconds, and then we can do a simple curl command and access our local. I mean the REST endpoint available at the slash hello. So this was the output. So this is what we have asked our application to do. So, and then the last method that I wanted to show is, so this is, so I will just comment out this part now because we already done this. And the last method is the Spring Boot way of containerizing your Java application. So in recent version with the Spring Boot Maven plugin, what you really get is this option over here that I'm just highlighting just now. So with this, if you run this option, you get a containerized uh, version of your Java application. And so let me just run that now.
Hey, and while you're running that,
Yep.
the understood, but why 51 years? So, like in your Docker images, the image that you downloaded from Docker repository, it had that it was 51 years old. Do you happen to know anything about that?
I think Jib does that for image reproducibility purpose. I mean, it chooses that time, so it removes any other timestamp. So typically, what I mean, this is just what I know. Maybe I may be wrong, but I think it's done for image reproducibility purpose, so that typically when you build your images, some the timestamp get changed, and then uh, your image digest can get changed with, if you, even if you are not doing any changes to your image.
All right, that's good. Thanks.
So what I have just started now is the Spring Boot uh, build pack version of containerizing your Java application. So this option is directly baked into your Spring Boot application itself, and so again it uses its own base image. So whatever is, it uses the packet to build packs. So it's just trying to pull in all those dependencies just now, and so it actually takes a lot of time with the, when you do a build for the first time, but subsequent build obviously takes less time once you have the base image downloaded. And another thing that I wanted to highlight is that it depends upon Docker daemon process. So mm, so if you don't have Docker running in your local, or maybe wherever you are running this option with your application, so it will not work because it requires a Docker daemon. It doesn't require a Docker file though, which is a good thing, but it has a dependency on Docker daemon. And with Jib, you don't have any dependency either on Dockerfile or your Docker daemon process. So which is really cool. So yeah, so it's just extracting the base image layers. So one thing, I mean, use this multiple times for just for my own learning purposes. So what I found out is that the image size is much larger as compared to Jib, and it sometimes it takes a lot of time, to, even if you run it subsequently, it takes more time as compared to Jib. So I did a small comparison. I will be sharing those stats in the slides as well, and it takes a lot of time. Yeah. And it has its own way of building your images, and it uses something called as Pacato Build Packs Builder, which I think you can see in logs. So it uses a builder image or something like that, and
Yeah, we have another question. What configuration needs to be added for Spring containerization? So you called this, and is it automatically included, or do you need to put a dependency in your POM?
I mean, I'm not sure if I get the question, but question is about how you can do different configuration with Jib. Is it?
No. What configuration do you need to add to a project so that you can do the Spring containerization? So, like you did Spring, you did a specific Maven command, and what plugin do you need to include in your POM so that you have access to that? I think is what
Okay.
you're asking.
For Jib, you have to add a plugin, but for this build pack integration, you don't have to add any plugin. It comes with the Spring Boot Maven plugin itself.
So, Spring Boot Maven. Okay, thanks.
Yeah. Yeah, so I think it's about to complete it. So, and build pack actually uses, I think, yeah, Bells of Librica JRE. So, and then I think in the final step, what it's trying to do, it's trying to load the image to Docker, local Docker daemon. So, yeah, so that only that part is pending. So it also has its own way of doing the image layers. It is similar to Jib in that fashion because it defines. So yeah, so the build is completed. But again, yeah, it took around 5 minutes of time. So 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 uh, let's just uh, stop this container first. Then we'll see whether we have them is available. Yep. So you see Pacato related. So yeah, so it has done that, and this is the final image version of our application. So yeah, even with this build pack, you see this 41 years ago. So I think it uses similar strategy what JB is using, and the image size is around 265 MB, which is much, as I was saying, much. It is much larger. I mean, not very significantly large, but it's higher than JB. Okay, so I think I'm pretty much done with my demo. I just want to go back to my slides and quickly complete the remaining part. So, so I think we all have seen zip build packs and Docker in action in the demo part, and I did a small comparison on different parameters, like how these different tools basically works. Like for example, ease of use, resource, the resource consumption, like memory, disk, and whatever, and time taken for your image building process. In that, have taken time for your first time build versus subsequent build, where you do no changes or some changes, and then how your image layer optimization is done. So I just have some of the stats for that. So in this criteria one, as I explained, so both Jib and Spring Boot, they are baked into your Spring Boot ecosystem itself. You don't really have to do set up things as you have to do for Docker. Like you have to have a Docker CLI and Docker daemon process up and running. With Spring Boot build pack, you definitely require a Docker daemon process, but with Jib, there is no such requirement. You don't have no you don't have any dependency with Docker. So very minimal configuration you have to do, and I think we have already seen that you just have to add the plugin, specify the target image and base image if you would like, and then with Docker, obviously there is a learning curve involved. You have to uh, do some mastery around the Docker commands, Docker build, Docker push, Docker tag, and so all those. So again, you required a separate setup with Docker. You have a complete setup in Docker CLI and Docker daemon process. And so this is some stats around the resource utilization. So there is one clearly one outlier, the Docker simple method. So if you see we have already seen that the simple method image was 664 MB around. So you see that one outlier over there, and rest of the, so rest of the part is pretty much if you compare it with the disk space utilization, then build pack is slightly higher. I think we have already seen that multi-stage build was a bit higher than the jib method. So by the way, I think I forgot to mention that you can even do your build with jib using Docker, but that's not people really use it for, because they just want to get rid of Docker. But it has that capability if you want to use it with Docker. So I have not explained it in the demo, but the these are some of the stats for that as well. So disk space utilization, yeah. So Jib is pretty much on the winning over here, and the memory consumption is. So this stats was taken using the Docker stats command. So when you run your container, the Docker stats command actually displays you like what is the memory consumption of the container that is actually running. So it gives you some idea. I'm not sure if it's very efficient way of knowing it, but it gives you some idea. Like so, again, the memory part, most of the options are pretty much same. The build pack and zip and multi-stage build. It took some more. Both the Docker option took similar amount of memory. And the third part is the criteria that I've used is the container image creation time. So in this, I have taken three different parameters. Is like time taken for first time when you do a build and push with your Docker image, and then subsequent build with no changes, and the subsequent build when you do some code changes. So Docker multi-stage build, as I think we have already seen it in the demo part, that even subsequent or first time builds takes a lot of time, And with Docker Simple, it's pretty much lesser than that. But I think I'm not sure if I have included uh, the Docker. I think I have included the Maven packaging part as well. And with Jib, if you see I mean the minimal option, the option that's come took least amount of time is Jib without Docker. So even the first time it took, uh, I think around within second, I think 30 or 40 seconds something, and then subsequent build with no changes are even much faster within 10 or 12 seconds, and then subsequent build and push with changes are uh, even much lesser.
Ashish,
And
is the build pack, is that the Spring Boot option?
yep, it's the
Okay.
Spring Boot build pack option. Probably should have mentioned that, but yeah, it's that option. So first time it took around, I think in our demo it took around 5 minutes or something. But yeah, so it takes sometimes it takes less than that. So this is just the average time that is around 3 minutes or something. And the build pack subsequent builds are, so it's compared to Jib, it takes a lot more time. And these are some of the image layers that is so these are some of the actual screenshot from the dive tool that I have just shown in the previous demo. And so so this is for the Docker simple version. So you have your jar on the right hand side, and then the total image size on the left hand side. At the bottom you see it's around 664 MB. And yeah, so so this is for the Docker multi-stage build. I think yeah, it's for Docker multi-stage build. And it took around image size 237 MB. Yeah. And this is for the build pack Spring Boot. So it has these many image layers. And so image layering is pretty much same with between Jib and build pack. And the total image size, I think it's around 258 MB. But yeah, maybe they have added some new things in our demo. I think it was around 264 MB or something. And this is for Jib. And so I mean the image size is again around 214 MB or something. So this is just, I mean, the way the image layering is done. Yeah. So if there are any additional questions that I can take.
Yeah, there are none.
Oh,
So we asked the questions as they came up. So um,
okay, cool.
yeah,
Yeah, so then these are some of the references that you can go through. So um, that this is the just the URL of the GitHub repository that we have used in this demo, and the article I have written some articles about Spring Boot application, how you can containerize with Jib. I mean, we have already seen that in demo, but if you want to go just for your learning purposes, and these are some of the facts that you can Jib related facts available on its GitHub repository. And this is the URL of the Jib GitHub repository. So, feel free to contribute it if you would like to. And last but not the least, I mean, if you want to connect with me, I'm available on Twitter, and I generally post about only technical things. And this is my GitHub username, and this is my blog URL if you wanted to do. So I have written some content around Spring Boot, Kubernetes, on Docker, Java, mostly all those things. And this is my LinkedIn username. So yeah, thank you. So it's pretty much done with my presentation.
yeah. Random guy says it was a great session.
Yeah.
All right. So I'd like to thank CRL and YRC again for sponsoring this meetup, and I'll let you guys go. All right.
Yeah. Okay. Thanks, Justin. Thank you.
Thank you very much.